In this video, we're going to be talking about the basics of what a solution is, its different components, how a solution actually forms, so what happens to the solute as it dissolves in the solvent, as well as some ways that you can speed up the process of dissolving a solute into a solvent. You are going to need a notebook and you are going to need something to write with. Once you have those things ready, let's go. So to start off as a review of what we're doing in Chapter 2, solutions are a homogeneous mixture, right? So every homogeneous mixture is a solution. The two components, we have the solute, which is the thing that you are trying to dissolve, and we have the solvent, which is what your solute is dissolving in. So for example, if we had a saline solution, your solvent is probably going to be water, and your solute is going to be sodium chloride, and maybe a little bit of sugar if it's medicinal saline, and maybe a few other things added into it. And also keep in mind that in general, the properties of the solution are closest to that of the solvent, right? So alloys are metallic solutions, so that means that an alloy is going to look like a solid metal. Solutions of gases, when they dissolve in liquids, will wind up forming a liquid solution, kind of like carbonated water, right? And then when you release the pressure, some of it will bubble up. And when you dissolve a solid in a liquid, your solution will look much more like the liquid than it does the solid. Now, water is such a common solvent that we have a term related to solutions that are dissolved in water, and that term is aqueous. Whenever you see an AQ in parentheses after a chemical substance, that means that that substance is dissolved in water. Most of the reactions we do in chemistry are wet reactions, which will take place in aqueous solution. So let's talk a little bit about water as a solvent and some of its properties. I'm sure you guys have heard before that water is what's called a polar substance. Polar basically means that one end of the water molecule is positive, in this case it's the hydrogen end, and one end of the molecule is negative, which in water is going to be the oxygen end. Now, because we have a positive side and a negative side, remember that opposite charges attract, right? So those positive and negative sides in the water can attract other positive and negatively charged substances like other polar molecules or individual ions in an ionic compound. Now, what water cannot do is it can't attract itself to substances that are nonpolar, though. Right? So oil is a great example of a nonpolar substance. Because the polarities are different, water is polar, oil is not polar, oil will not dissolve in water. That gives rise to the phrase like dissolves like. A polar solvent will dissolve polar substances and ionic substances to some extent. Nonpolar substances, though, only dissolve in nonpolar solvents. So if I wanted to dissolve oil in something, I'd probably need to dissolve it in something like cyclohexane or maybe gasoline, because those are nonpolar options. So now we need to go over a little bit about how a solution forms, especially an aqueous solution because of how water works. It's a two-step process. The first process is what we call dissociation. Dissociation is when the water molecules break apart the solute into individual pieces. Now, if we're talking about an ionic compound like sodium chloride, that will be dissociated into its individual ions, sodium ions and chloride ions. If it's a molecular substance, then what you'll see is it will pull apart individual molecules. So if we were trying to dissolve sugar, for example, it would pull off one sugar molecule and dissociate that, pull off another sugar molecule dissociating that. Once our solute is dissociated into individual particles, water will then surround those particles in a process that we call solvation. Right, so for polar substances or ionic substances, this is where the fact that water has a positive and negative side matters, because our hydrogen side of the water molecule, which is positive, will surround the negative ion or the negative part of a polar molecule. And then the oxygen side, because that's negatively charged, will surround the positive ion, or the positive part of a polar molecule. And what I have on this slide is an example of what this looks like. So this is crystals of sodium chloride. So we have a giant salt crystal, lots of individual sodium ions and chloride ions in this crystal. So in the first step, what's happening is that the water molecule is going to pull off those individual sodium and chloride ions. And then in the second step, as we can see in the diagram, the oxygen side of the water molecule, because that's negative, will surround the sodium ion. And then the positive side of the water molecules, because that's what the hydrogen side does, will surround the chloride ion because that's negatively charged. And what you're going to have is you're going to have these positive and negative ions basically suspended in water. Right? So this is how water goes about dissolving things. Polar molecules work the same way, except instead of having a sodium ion, you have the positive end of a polar molecule. And then on the other side, where your negative end is, that's where the hydrogens will wind up being. Right, so that's how water will go about dissolving other substances. So let's talk about rate of dissolution. So how can we make something dissolve faster? Right, so things that affect how quickly a solute will dissolve. We'll start off with size. Right, the more surface area it has, the quicker it dissolves. Because remember, it has to pull those individual molecules off. The larger the surface area, the more molecules or ions it has access to, so it can pull them off quicker. And the example I give here is we're just going to use T, kind of going forward for all four of our examples. If we put a sugar cube in a cup of tea versus like a spoonful of granulated sugar in a cup of tea, the granulated sugar will dissolve a lot faster because it has a lot higher surface area. The particles are a lot smaller than normal. The second thing that will affect it is the state of the solute compared to the solvent. If the solute and solvent are in the same physical state, solid, liquid, or gas, they will dissolve a lot faster. Right? So this is where we get the idea of if we dissolve a spoonful of sugar in our tea versus like if you go to Dunkin's and you ask for the liquid sugar, or what's called simple syrup, that's already in liquid form, so when you pour that in, it dissolves almost instantaneously. Whereas the granulated sugar, you have to kind of stir it around for a couple of seconds in order to get it to mostly dissolve. The third thing that affects how quickly a solvent will dissolve is the type of mixing that you do. Right? Because what happens when you mix the solvent, so when you stir it or whatever, is that you bring in fresh solvent particles that can then attack and surround the individual solute particles. So again, if we have our sugar in tea, if I just poured a spoonful of sugar in and let it sit on the bottom and dissolve, it would probably dissolve over the course of like an hour or so. If I stirred it, it would dissolve over the course of a few seconds. Or inverting. Inverting is actually the fastest way to mix a solute into a solvent because you get it to go through the entire solution. So inverting a few times is actually much more efficient and it will cause your substance to dissolve faster. And the last factor that can affect how quickly it dissolves is the temperature of the solution. Right? So if you try to dissolve something in a warmer solution, it dissolves more quickly because those particles have more kinetic energy, which means they're moving faster, so those solvent molecules can get out of the way a little bit quicker. If you've ever seen sugar trying to be dissolved in iced tea versus a regular cup of tea, you dissolve sugar in iced tea and what happens is that you get like this sugar sludge at the bottom of it because the solution is so cold that sugar is just not very soluble at that temperature. Whereas something that's like 85 degrees Celsius, sugar will dissolve a lot more readily at that temperature. Okay, so that is our video on the introduction to solutions, kind of how they form, how a substance will dissolve, and ways that we can affect the rate of dissolving. In the next video, what we're going to talk about is we're going to talk about a concept called solubility. So how much solute will dissolve in our solvent. I will see you guys later.